Video here today is going to be about covalent compounds, and more specifically just about how covalent bonds come together and the properties associated with those covalent compounds. We're going to spend a lot of time talking about these down the road and actually how they're formed and all that. I just want to give you a little bit of a description about them themselves. So here what you see are a lot of examples of some covalent compounds. And hydrogen, oxygen, all of these right here are called molecules. Molecule is the name that we use to describe a covalent compound. Now when we're talking about a covalent compound, we're talking about the sharing of valence electrons. Okay, so we're not talking about giving and receiving. There's no ions associated with it. There's no delocalized electrons. We're simply going to be sharing our valence electrons. And the reason that we share valence electrons is to reduce energy. The reduction in energy leads to increased stability for the atom. So it's actually more advantageous to pair up with someone than to stand alone. An example that I might give is if you were to go camping, and you were to go camping with a friend. If you divide up the number of tasks that need to be completed, there's still the same number of tasks that need to be completed each night. You need to set the tent, you need to gather firewood, you need to cook, you need to a lot of different things. If it's just you alone, then you're forced to do all those things. It requires more personal expenditure of energy. If, however, you go camping with a friend, you can split up the tasks and therefore use less energy overall. A covalent bond, therefore, then, is the sharing of valence electrons. It's the coming together of outsides. So a covalent bond, then, would be formed by the sharing of electrons. And again, this is for stability purposes. And again, we still want to get to 8. So when we're talking about sharing valence electrons, we're talking about sharing to get to 8 rather than giving or receiving to get to 8. And typically what we're talking about are our nonmetals. Nonmetals tend to do most of our covalent bonding. Now there are few in variety for nonmetals, but there are a great abundance of those nonmetals on the planet. When these come together, again, the term that we use for them are molecules. The properties associated with covalent compounds are a little bit different. So here are 3 examples of some covalent compounds. Here we have sugar. Here we have sugar in a slightly different form. This is the marshmallow. And here we have something quite a bit different than the other 2. Here we have another covalent compound. This is diamond. So there's a great deal of variety in those. Now, you would look at sugar and say, hey, that's pretty solid, okay. But if you hit a sugar crystal hard enough, you can break it apart. Marshmallow, that's a very, very soft solid. Diamond, on the other hand, is the hardest substance known to us. And it has everything to do with the number of atoms involved. The more atoms, the greater the stability, the greater the strength, the higher the melting point, the higher the boiling point, and also the difference in the state of matter. The more connections there are, the more likely it is to be like a solid. The less connections, more like a gas. Now, some of the other properties associated with covalent compounds are that they are poor conductors. And now the reason behind the poor conductors is because we're sharing electrons. There's no movement of electrons. So when we were talking about ionic compounds and we were talking about metallic compounds, we talked about good ability to conduct electricity and heat. Well, for ionic, we're moving those electrons. We're giving one to the next. So there's your movement. Now, as a compound themselves, they only conduct well in solution as an electrolyte. But when we talk about metallic bonding and metallic properties, we're talking about a free flow, delocalized set of electrons. In the flow of electrons, that's the conduction of electricity. Further on, covalent compounds tend to be brittle. They will fracture rather than condense. And the last thing, as I mentioned, they are not electrolytes, meaning when you place them into water, they don't conduct electricity any better than they did as a solid. This is a brief overview of covalent properties. You should think about comparing these to ionic and metallic.